All right, second day of nomenclature. We are going to be doing these ternary compounds that require knowing your polyatomics. Okay, so I need all the cell phones to be put away, please. So I know it's hard for y'all to see in class. It's pretty easy to see on the video, but this is a ternary compound flow chart that kind of explains. Can y'all still see your paper with the lights off? How about you? You good? Good. I can turn it back on if we need to. No. There is no need to struggle. Maybe if I do half. Half's good? Okay. All right. So when you ask the same questions that you did yesterday, the only difference is there's a polyatomic attached to these, which have different names. These names ending in "ite" or "ate." There are only two IDE polyatomics, and that's the cyanide and the hydroxide. The rest of them are going to end in "ite" or "ate." Okay? And what you do is, again, decide, is your metal multivalent? If it is, you need a charge, so you got to put that Roman numeral there. And if it's not, you just name what you see. So this number 15, looking at the first one, this is obviously two polyatomics shoved together. Super easy to name. What is this one called? Ammonium nitrate. Good. If you don't know what's going on with these polyatomics and you don't know them, you need to get out that list right now, because this class is going to be pointless if you're just going to sit there and stare, because I want you to be able to start learning them as we're doing this kind of thing. All right, potassium, does it have more than one charge? No, so what is this called? Potassium, which one? Trite. I want to make sure I heard you. Nitrite. Okay, this next little guy right here is a perchlorate. Now, when I teach this, I like you to see the pattern of 4 that exists with 4 different halogens. And if you know the pattern, you memorize 16. Boom, right off the top. So if you think about this particular thing, it works with the chlorine halogen, the iodine, the bromine, or the fluorine. And the pattern is this. I'm just going to do chlorine. Chlorine is with 1 O as a negative, 2 O's as a negative, 3 O's as a negative, and 4 O's as a negative. Okay? So the ite and ate are the 2 and the 3. So this is chlorite, and then that's chlorate. The one with the 1 O is hypo something ite, hypoite. So that's hypochlorite. You see how the ites are close together? And then this guy right here is a per something ate. So it's a perchlorate. And see how the eights are together. So this works, like I said, with the 4 halogens. We can have hypoiodite, iodite, iodate, periodate. Again, with all 4 things. So that's 16 polyatomics you can learn like that just by knowing this pattern. Okay? So going back to this example, calcium, does it have more than one charge? Nope. So what do we do? Calcium perchlorate. I'm going to see if I can make this pen a little thinner. Yeah, I can. Okay. All right, now we're up to a copper-containing compound. Does copper have more than one charge? Yes, so we have to decide based on that polyatomic what copper's charge is. What's that polyatomic called and what's its charge? Carbonates, it's a what? -2. So what does that mean copper's charge is? 2. So we're going to call this copper 2 carbonate. Okay. Now, this next one has that polyatomic that ends in an IDE. Sodium only has one charge, so what's this called? Good. Sodium cyanide. All right. The next one, barium. Does it have more than one charge? No. So what's this one called? Barium sulfate. What do you do with the dead chemist? You bury him. All right. This next one, just be careful with your charge. Okay? You've got Hg2O. Does Hg have more than one possible charge? Yeah, it does. So the oxygen's a -2, so everything on the left has to be a +2. But you got 2 mercuries, right? So how much is each one? 1. And that works because remember we said this exists as a polyatomic. That's mercury plus 1. So we're not breaking any rules here. It looks good. So what do we call this guy? Mercury 1 oxide. If you need me to slow down and re-explain something, now is the time to ask. Okay, because we're never again going to just do nomenclature. Okay, well, you don't need to know this whole mercury 1 thing to answer this question. If we have Hg2O, we know that oxygen's -2, correct? That's +2, but there's 2 of them. So what I did here was just remind you yesterday, we can't have +1 unless it's a diatomic, and that's what's going on here. Okay, going down here to this sodium compound. This is a polyatomic of carbonate with a hydrogen in front of it. There's 2 acceptable names to this. You can say hydrogen carbonate as the ion or bicarbonate. Have you all heard of sodium bicarbonate? Yeah, what is that? Exactly, that is baking soda. So you're allowed to just say sodium bicarbonate or sodium hydrogen carbonate. I don't care which one, I have no preference. Yes. No, it's not hydro, because hydro means something different. Hydro refers to, hydro refers to water, when you do a hydro something. So it's got to be hydrogen. Yeah, that would be something else. Okay, so now we're going to go the other direction. We have lithium being what charge? +1. Carbonate is what? CO3 -2. So what's my formula? Li2CO3. Now I'm going to show you something I don't want. I see students in their thought processes and their desire to try to make things cancel and balance out. I see them doing things like, oh, that's a plus and this is a -2, and then answering like that. I don't want to see anything near this compound. You can't give, and as an AP grader, we mark off, we don't give credit for names that are written like that, okay? You keep the charges away from the name. There are no charges in formulas unless it's an ion, okay? This belongs to Hannah. I don't know what it is. Can you pass that back to her? Looks like a schedule. All right, let's go to the right. Zinc nitrate. What's zinc's charge? +2. Nitrate is NO3 -1. So what would our formula be? And I heard someone say parentheses, and that is correct. You have to have parentheses if you have more than one polyatomic. You cannot have parentheses if you only have one. That's bad form. I see a lot of students doing stuff like this because they don't remember, and then they're like, oh, there's only one, so they leave it like that. That's bad form. We're in AP now, so we're going to write things appropriately. Magnesium hydroxide. What's magnesium's charge? +2. Hydroxide is OH -1. And so what are we going to get? Mg parentheses OH2. Okay? All right, strontium sulfate. Strontium is +2. Sulfate is SO4 -2. So what's our formula? SrSO4. Might be a polyatomic weekend for you guys. All right, lead to permanganate. We don't have to look at the periodic table because they're telling us that lead is what charge? +2. Permanganate, MnO4-. See that per thing again? 4 O's? It happens. All right, what's the formula? Pb, MnO4-2. All right, iron 3 cyanide. Iron, they're telling us, is a +3. Cyanide is that Cn -1. So we're going to do Fe parentheses Cn3. Okay. All right, chromium 3 chlorate. It's chlorate. All right, so chromium is a +3 because they're telling us. What's chlorate? Think of the pattern. ClO3 minus. So what would my formula be? Three. Acetate's a good one. Acetate's one of those that we're going to use in AP constantly because acetic acid is a weak acid, and when we get to solutions right after Christmas, we run with this guy a lot. So the acetate ion is C2H3O2 minus. So lithium is a +1, C2H3O2 minus. You might see this one written as, well, I'm going to wait. I'm going to hold off on that. There's different arrangements of that. Just count your C's and O's when you're looking at things, and if you have that many, and if it's arranged differently, it's going to be the acetate. So this is just lithium C2H3O2. Okay? All right. So now these are mixed up. We're going to have from all sorts of stuff. So starting with the first one, the first question you ask yourself, is it ionic or covalent? That thing with the sodium is definitely ionic. Does it have more than one charge? No, so we just name what we see. What do we see? Sodium sulfite. Good. Okay. I don't know why I changed from going down the column to across. And now I'm in the mood to go down the column. So, ionic or covalent? Covalent. So what do we do? What do we use? Prefixes. So what is this called? Sulfur dichloride. All right, the next one, ionic or covalent? Ionic. Does potassium have more than one charge? Nope, so we just name what we see. Potassium what? Permanganate. Permanganate. I'm running out of room. All right, MnO4, ionic or covalent? Ionic. Does Mn have more than one charge? Oh, yeah. So I'm going to have to use the oxygen and how many oxygens we have to figure out what that charge is, right? So I'm going to write down manganese. If I have two oxygens, each one at -1, -2, that makes that right side -4. So the charge on this guy has to be 4. So manganese 4 oxide. All right, top of the next column, MgSO4, ionic or covalent? Ionic. Does manganese have more than one charge? No. What's it called? Magnesium. Did I say manganese? Sorry, guys. It's magnesium. Might be. Magnesium sulfate. CrPO4. Ionic or covalent? Ionic. Does chromium have more than one charge? Yes, so I have to say what the charge is. Chromium is singly attached to a what polyatomic? Phosphate. What's phosphate's charge? -3, so this is +3. So chromium 3 phosphate. All right. Ionic or covalent in this cobalt dude? Ionic. Does cobalt have more than one charge? Yes. So I have to figure that charge out. If you look, I know this is a carbonate at a -2, right? I've got 3 of them, so that makes the right side -6. The left side would have to be +6, right? But I got 2 of them, so each one is a +3. So this is cobalt 3 carbonate. SO3, ionic or covalent? Covalent. So I use prefixes. What's the name? Sulfur trioxide. Okay. Now we're just going to write more formulas. So I'm going to try to do this section without breaking down the charges too much. Let's see how good we do. It's chromium 6 nitrite. So it would be what? Cr, NO2, 6. I know that seems really big and weird, but chromium in this problem has a 6. Sulfur dioxide, SO2, that one's easy. Ammonium iodide. Ammonium is that NH4 plus polyatomic. It's the only plus polyatomic we're going to deal with. And then there's I minus. So we just shove those together. NH4I. Copper 2 phosphide. Copper has a plus 2 phosphide. Is that a polyatomic? No, it's just a P. IDE. So we get it from there. And what's its oxidation state or its charge? -3. So I have a Cu what? 3P2. Nickel 2 hydroxide. Nickel has a plus 2. Hydroxide has a -1. So what's my formula? Good. Ni parentheses OH2. Now, if you have your polyatomic sheet out, you might want to add this one. I keep forgetting to add it. Peroxide has its own polyatomic. Peroxide is O2 minus 2. You've heard of hydrogen peroxide, right? And you know the formula for that. For some reason, everybody knows it, which is what? H2O2. You've heard that before, right? They have there's a joke about Johnny drinking water. And then the waiter's and then he's like, I'll have some H2O2, waiter, and he brought him hydrogen peroxide, and then he died at the table. Anyway, so peroxide is its own polyatomic. So knowing that it's that, what would sodium peroxide's formula be? Na2O2. Nice. All right, osmium 8. OS 04. There are very few of you saying that. Why? Let's not be confused. This is a +8. This is a -2. So we need 4 oxygens, right? Okay. Gold 3 chloride. Gold's a +3. Chloride's a -1. So it's AuCl3. Okay. So that's ternary nomenclature. Now we're going to review and do acid nomenclature. You guys will be fine. This is not that hard. So there's 2 types of acids. There are the binary acids, which just have 2 kinds of elements in it, an H and some sort of element. Another thing that these binary acids have in common is everything that we would look at, all the ions that we attach to H's, end in IDE. Phosphide, sulfide, cyanides included. Anything that ends in an IDE, we're going to name it hydro-something-ic acid. So HCl would be hydrochloric acid. H3N, hydronitric acid. Again, because that's chloride, that's nitride. If they end in an IDE, it falls under binary. Okay? But we have acids that have polyatomics in them. If they have polyatomics in them, we know that it's going to end in an ite, an ite or an ate. This is really simple. If the polyatomic ends in an ite, you just change the name of the acid to end in an us. If it ends in an ate, you change the name of the acid to end in an ic. So let's say we have HNO2 versus HNO3. This is nitrite, so the acid would be nitrous, ite-us. This is nitrate, so the acid would be nitric. So we learned a saying in Chem 1, depending upon your teacher it varied a little bit, ic, I ate a humongous bite. So if the acid, or the polyatomic I should say, ends in ate, the acid's going to end in ic. Those two go together. Icky ate, ick I ate, ick and ate go together. If it ends in ite, the acid will end in us. Okay? So I think it's just best to jump in and do them. All right, now, start out, of course, with an exception that we need to talk about. What's the difference between these 2 things? One's gas and one's aqueous. Acids, in acid nomenclature, we always want to do as aqueous solutions. All the acids we're dealing with are aqueous. When you have something like that first HCl in the gaseous form, we don't call it hydrochloric acid, okay? What we're going to do, if it's gaseous, we're going to name it as if it were an ionic compound. If I were just going to name that as an ionic compound, what would that be called? Hydrogen chloride, and that's what that is called. And now it's not, people are like, why isn't it hydrogen monochloride? That's covalent. Well, this does dissolve in water and form ions, so we treat it ionically. Okay? That H makes it weird. That's why the H kind of, when I say it belongs on the left side of group 1, that sometimes it belongs over the halogens, it really, truly does have different characteristics. But this one's aqueous, and if it doesn't say what it is next to it, you can assume it's aqueous. This was just done to make a point. Okay, so HCl aqueous, what are we going to call that? Hydrochloric acid. And I'm just going to write acid for the first one. I'm not going to write the word acid on every single one because of my handwriting and the size of the line I have on this board. All right, HClO4, what's the name of the polyatomic in there? Perchlorate, so what's the name of the acid? Perchloric. H2CO3. What's the name of the polyatomic? Carbonate. So what do we call the acid? Carbonic acid. Why are there 2 H's on that one? Because the polyatomic's charge is -2, so there has to be 2 positive H's. Right? HClO, what is ClO minus's name? Hypochlorite. So what would the acid name be? Hypochlorous acid. Okay, the sulfur polyatomics and the phosphorus polyatomics, the name's a little different than what you might think. This is sulfate, right? What's the name of the acid? Sulfuric. It's not sulfic. A lot of students want to say sulfate, sulfic. No, sulfuric. Sulfuric acid. And then H2SO3 is sulfite, so it's sulfurous acid. And the same thing with phosphorus. It's kind of weird. PO4 minus 3 is what? Just the name of the thing, phosphate. So what's the name of the acid? It's not phosphic, it's phosphoric. Okay, we'll go the other way. Hydrosulfuric acid indicates what kind of hydroic? What does it indicate? Just got 2 elements in it, right? It's got an H and an S. So how do I combine H and S to charge balance? H2S. Nitric is telling us what polyatomic? Nitrate. So how do I put hydrogen and nitrate together to balance? HNO3. Hydrocyanic acid. The hydro means it ends in an IDE, right? So that is what polyatomic? This is normally not a polyatomic if it's hydroic, but it's the one polyatomic that ends in IDE. So what's the formula for this guy? HCN. Periodic, what polyatomic? Periodate. Periodate is a -1, and it's the IO4, -1. Acetic. I just want you to just know this really well. Like, this needs to be your best friend. So it's HO2. It's our acetate ion. Okay. Hydrobromic. That means it's hydroic, which means it's binary. So what 2 elements are here? HBr, and Br is -1, H is +1. There we go. Phosphorus comes from which polyatomic? Phosphites. And what's the charge on that? -3. So it's H3PO3. Oxalic comes from oxalate. Does anybody remember that? Very good. I heard JD all the way in the back. rocking out the oxalate. And what's our formula then? H2C2O quattro. I think that's it. Is the next thing. Are there any more naming? Are we done? Oh, because that's the end of your packet. So I'm glad that I see that, because this is a little reminder that starting on Monday, I'm not providing you with any more of the handouts. You either have to, A, download them from the chemistry website, not from Google Classroom, from the chemistry website, and onto your iPad into a note-taking app. You can, B, download them and print them on your own, or you can, C, go to FedEx and purchase all of the year's worth of handouts for $5.70. All right? Okay, that's it.